One-sided limits. Some functions have no limit at a point. For these functions, it is appropriate to look at their behavior at this point from one side only. And when we want to study the behavior of the function on just one side of a point, we use one-sided limits. By the way, if you like this video, don't forget to like and subscribe to this channel and activate the bell. It is very important for the continuity of this channel. Sometimes indicating that the limit of a function does not exist at a point does not give us enough information about the function's behavior at that particular point, since when a rational function doesn't have a limit on a given value, the values of the function in the graph have to go somewhere. Look at the graph. This function has no limit as x approaches 4. Even though the function has no limit at this point, we can still say something about what's happening to the function around this point by using the idea of one-sided limits. Now we consider a function with a defined limit. The limit of f of x when x approaches 0 is 2. One-sided limits work like regular limits, except that x approaches the x number from just the left or just the right. To indicate a one-sided limit, you put a superscript subtraction sign on the x number when x approaches the x number from the left, or a superscript addition sign when x approaches it from the right. The limit as x approaches 0 from the left is 2. The limit as x approaches 0 from the right is 2. One-sided limit tells us what a function is doing at an x value as the function approaches from one side or the other. We now define two types of one-sided limits. Let f of x be a function defined at all values in an interval containing the number k, and let L be a real number. Limit from the left. The limit of f of x as x approaches k from the left, x is less than k, is L, or the left-hand limit of f at k is L, denoted by the limit of f of x as x approaches k from the left is L. Similarly, we define the limit from the right. The limit of f of x as x approaches k from the right, x is greater than k, is L, or the right-hand limit of f at k is L, denoted by the limit of f of x as x approaches k from the right is L. Look at the graph. The limit from the right means that x approaches k from values greater than k, and the limit from the left means that x approaches k from values less than k. Let us now consider the relationship between one-sided limits and normal limits. It seems clear that for the limit of a function to exist, as it must be true that both one-sided limits exist and are equal. The following theorem states just that if f is a function and k and L are real numbers, then the limit of f is equal to L if and only if both the left and right limits exist and are equal to L. Mathematically, it can be written as follows. Let's see how it works. Determine the limit if it exists by evaluating the corresponding one-sided limits. As x approaches 0 from the left, f is approaching the value of -1. As x approaches 0 from the right, f is approaching the value of -1. Since the limit of f as x approaches 0 is -1 from both the right and left, the limit of f as x approaches 0 exists and is -1. It is clear by looking at the graph that both the left and right-hand limits of f of x as x approaches 0 is minus 1. Thus, it is also clear that the limit is minus 1. Let's see how to evaluate the limit of an absolute value function. We begin by rewriting the absolute value as a piecewise function. We now evaluate the one-sided limit. As x approaches 2 from the left, f is approaching the value of minus 1. As x approaches 2 from the right, f is approaching the value of 1. Since the limit from the left and values, the limit of the function does not exist. It is clear by looking at the graph that both the left and right-hand limits of f of x as x approaches 2 are not equal. Thus, the limit of the function does not exist. Let's evaluate the limit of an absolute value function again. We begin by rewriting the absolute value as a piecewise function. We now evaluate the one-sided limit. As x approaches 1 from the left, f is approaching the value of 0. As x approaches 1 from the right, f is approaching the value of 0. Since the limit from the left and the limit from the right take on equal values, the limit of the function exists, and it is 0. It's clear by looking at both the left and right-hand limits of f of x as x approaches 1 are equal. Thus, the limit of the function exists. Let's see another example. If x is greater than 2, then x minus 2 is positive, and the square root is defined. So, as x approaches 2 from the right, f is approaching the value of 0. But if x is less than 2, then x minus 2 is negative. Taking this limit would require us to consider the square root of negative numbers, an operation that's not defined. So, we cannot let x approach from the left. The limit from the left does not exist. In order to say that the limit exists, the function has to approach the same value regardless of which direction x comes from. Since that isn't true for this function as x approaches 2, the limit does not exist. Let's look at 2 more examples. You should try to solve them yourself and then check the answers.